Okay, so I'm not feeling too great today. I'm not going to program too long. I'm going to try to figure out the color stack for a capstone on a laystone of the same color. So if I take this white capstone, see how it's invisible once I go over that laystone? And then once I drop it, and then lock in that move, there's a capstone on top of that white stone. You just can't see it. And then if you were to pick it up, you could drop one and reveal the capstone underneath. So we're going to do something similar to how we added a little border around our blacks and whites so that you can see when the same color is stacked on top. We need to do something similar to the capstone. So we need to kind of render a different color border like right around it. But the hard part is it needs to be adaptive to the stack order, because as they shrink, the shadow needs to shrink as well. But if we take a look here at our members, we've got the code here for the shadow. See, this sets color for the border, sets color for standing stone. Okay. So we need since standing stone is horizontal, it's easy to read on top of... Actually, no, that's another thing we need to fix. Shoot. We need to fix a standing stone on top of the same color too. Because if we move a black standing stone on top of a black lace stone, it also disappears. So that one's really tough to fix, because if you take a look at our standing stone here, that's the code for it. And that's just to get it at the right size. Jesus Christ, I can't believe I figured that out. But the right size for the adaptive shrinking, depending on the stack order. But we'll need to do something similar as a border for that. If we take a look at the border we did for our lace stones, we'll see that we I'm not exactly sure where we're doing it. So we set the color for the border, we render the border, and then we set color for the real color, then we render the real color. So if we look at the difference between this line and the next line, we'll see that the only difference is +2 on the X. A +1 on the X, a +1 on the Y, and and we shrink it by 2. So we shrink the width and the height by 2, and then we move the origin point to be down and over just 1 pixel, so we have 1 pixel of border. That's for our lace stone, but we need to do that for our capstone and our standing stone. So let's try our standing stone first. So this renders the real standing stone. Now we need to do something similar where we can say we want the X to be 1 pixel offset, one to the right, and then 1 down. So we offset the original, then we actually shrink the width and the height. By 2 pixels. So now our standing stone should be shrunk just a little bit. So if we drop just a standing stone in our grid, we'll see that we actually have 1 pixel of border here, but it's still centered. So what we're looking to do is render exactly what we did have at the darker color, and then render this one on top of it, and that way it'll give us a little border outline. So we did our shrinkage here, but we need to set the color to this gray color. Now we have two different colors. If it's white, it's a little bit darker of a gray, and if it's black, it's a little bit whiter of a gray, I'm pretty sure. So I'm just going to set our colors here. No, I'm just spacing out. Okay. Now we can set the appropriate colors, just like we do up here. So we set the appropriate color. Then we need to render. Then we need to render the full size stone in the shadow color first. So instead of our +1, our +1, and our +2 and our +2, or our -2 and our -2. Instead of that, we're doing the full size at that shadow color. Then we need to reset our stone color for the real stone. Then we'll say this sets shadow color, that sets actual color, and then we render the real one. Let's see if we can now stack standing stones and have it read. So we can move a black standing stone onto a black lay stone, and now we can actually see it. So that worked like a charm. But our white works too. The question is, does the scaling work as it gets smaller? So if we populate a tester stack of, in our place state here, in our place state, if we populate a tester stack of, let's say, 13, let's see. So we want to place a white standing stone there. So if we take a look, look at that little border. That's so cute. Now you can actually see it on there. That's great. So it looks like that's working. That was easier than I thought it was going to be. I already did the work of figuring it out last time, but the circle is what I'm really worried about. The capstone is what I'm thinking is going to be tougher. So here we are rendering a normal size capstone, but we need to do this similar thing here where, depending on our color, we need to set our shadow color first, and then we set our shadow color first, and then we need to render this, but normal in the shadow color. So we'll have that just like that, but then we have to reset our actual stone color, and then once we have the regular stone color, we have to render a slightly smaller circle. So the question is, how do we offset the X and Y based on the radius of the circle? because the radius gets set upon the stack order. So I believe the arguments is x, which is this, y, which is this, and then a radius, which is this. So how do we set an x offset depending on the radius? I feel like pi's involved. Well, actually, oh, this is easy. This is easy. We just because the x and y of a circle is actually the origin point right in the middle. So all we have to do is shrink the radius by however much we want the shadow to be. So we would want our real circle to be a little bit smaller. So what if we do this divided by 2.9 or something, and see if that's readable. Does that look like we have an outline there? What if we shrink it by a lot more? Can't really see it. Yeah, I can't really see it. Now we set our shadow color and we're rendering it shadow, so this needs to be what if we take our whole radius and we just shrink it by 2? I don't know how big of a difference that might make. I'm just wanting to see a difference. There we go. I can see the shadow there. You guys see it? Little gray shadow there with the 2 radius. I guess the interesting thing is in our hand it doesn't seem to be rendering that shadow. So if we had a lace stone, then that. So how are we not rendering the shadow on the mouse stone? Only when we place it. How are we doing that? Where are we doing the mouse stone render that we're not doing? Right here. We're rendering a mouse stone of 50. Is that the same? Oh, we render a full-size capstone. Unless it has. So like there's an exception to where the mouse stone would render it would actually render the capstone here if we had the capstone on top of a stack like this. Oh, look at that, that's cool. See, that's too thick, we need to fix that. But at that point in the mouse stone, it would render that. So we just need to, that's interesting. Okay, we just need to shrink our mouse stone here. You know what? I don't know how I feel about this. Because the thing is, we aren't actually... The weird thing is, we're not actually populating... Yeah, this is kind of weird. We're not actually populating a mouse stone's object don't know exactly why we're not doing that. We're just rendering it separately. I don't exactly know why we're doing that. I think because I didn't want to go through the hassle of cycling our stone type of our mouse stone members, but that's actually really simple, so I don't exactly know why we're not doing that. We'd have to modify... Oh, yeah. I don't know how we would modify the arguments to a love.draw function in a member. I'm not exactly sure how we would do that. I guess if I think I don't know what to do. I think once we figure out the scaling for the stack order, we can come back and do the explicit shadow render for the capstone and standing stone. So instead of this -2, what if we do a minus shrink? Let me just see what that is, because shrink starts out, well, shrink is a constant. Starts at 8. That's going to be way too big. What if we do a I don't know. How would we adaptively scale the capstone so the shadow renders appropriately sized? Instead of a constant, we would need it to be something different, because the constant made it worse. It made it a thicker and thicker border the higher up. So we don't want a constant here. But what do we want? We want a value that gets smaller the higher stack order it is. So if we divide by the stack order, let's just see what the, if we divide by the stack order, what that gets us, then we can modify how much that's shrinking by. So let's see what, so that looks pretty thin. Let's see. Look at how thick that one is. It'll get even thicker here. It might even crash. I don't even know. Jeez, yeah, it gets even thicker. So we need it not to be by that. What if we do it by a stack order divided by... I don't fucking know. Stack order. I'm really just guessing. I don't know what the heck's... I don't know how to... Oh, lordy. Uh-huh. Yep. Maybe it's a tad too big. That so we need to modify this value right here by something that gets smaller the higher the stack order it is, but us just doing a stack order is way too fast of a difference. So we need to know how to figure this out. I don't know how to figure this out with math. I don't know how to figure this out with math. So what if... Okay. So this is the radius. Wait a second. Oh. Wait, hold on. We need to... Dividing by a 2.75 constant is what we do to shrink based on the stack order. So what if we shrink it by less? It should, the original stone should be a bit bigger than the outline. Is that looking like that? Great. Look at that, that's close. I mean, that rendered a little border for that one, but I'm not really seeing the border for the full-sized stones. If you look here, we're actually doing like a tiny bit of a border, so it's almost working. It's almost working. What if we do it by a little bit less? That'll make the beginning ones look better, but the ending ones look worse. Like, lower stack order ones would look more passable. Yeah, see, that's good for the lower stack order. See that? We can see that border. But if we were to put a white stone in a white grid at a higher stack order, see how much that one's off by? So we need to find some middle ground here where we can keep this one about the same and then make the bigger stone render a little bit bigger by the time its stack order gets to be bigger. So this is fine. Let me... I don't know how to do this. We need to modify... What if we... I don't know. It needs to be a bigger number by the time we have a higher stack order. So how do we do that? It's already a bigger number, but it needs to be an even bigger number at a higher stack order. So maybe we modify this whole thing with a we need to offset it by factor of a self-stack order, and that factor needs to be low when we're a low stack order. So if it's a stack order of 1, what if we do this stack order divided by, I don't know, 0.3? Let's see. We can't really see that. 1 divided by a 0.3. We need to scale it by a 0.3, I think. I don't know. We can almost see it, so we need to scale it by less, I think. So maybe a 0.8, because we still want to be able to see it at a stack order of 1 or 2. Here we go. I can't really see it, huh? I'm really just guessing. Okay. That one's looking okay. Let's see if we could place a white capstone at a higher, well, a higher stack order. There we go. I mean, it's the same problem. We just need to fix. We scale this. Is this an idea that's working at all? We can kind of see that. Okay. So let's figure out what the high end for the stack order is. If that's a stack order of 14, we know we need it to look good there. So if we do, if this is a 0.8, does that make it better or worse? Worse. At 0.5, let's see how that's looking. That's just about perfect for that size. So let's see how the normal one looks. It's not quite there. So let's see at what point we can actually see it. Can we see it at a stack order of 3? No. Can we see it? Great. If we have a stack order of 5, can we see it there? Oh, we need to see black on black. Shoot. Oh, God. What's the freaking code for this? How do you adaptively shrink a shadow based on a radius of a circle? It's hard because the radius is adaptive. I don't know what to do here. Maybe we make this. Let's see how that looks. So a white there is readable. Is a black readable here? Hardly. Not. So if we make this 0.4, does that make it better? White. Sure, that's readable. Black on a black at a low stack order. Hardly. You can't even see it. It's even worse. So we need to go the opposite direction. So instead of going from 3 to 4, we need to go to 2.8. 2.6 or 2.5 or something. Let's see what that gets us. Okay, white is readable. And let's hope black is readable, kind of. It's... You could kind of see it. Ideally, we shrink this. Maybe now we just tweak this a bit, and maybe that'll fix it. I'm literally just guessing. Okay, that's looking okay. Can't really see it. So what if we, if does this is a bigger number, is that better? Worse. Okay, that's worse. So instead of a 2.3, maybe we do a 2.2. No, we were at 2.2. Let's try 2.1. Okay, it's readable, not perfect though, but let's see. That's just barely readable. So I guess it's like, it's still not quite there. We want this to be 2.2. Is that readable at all at a stone stack of 1? That's readable. That's just not readable. I mean, you can see it, but I'd like it to be better. So what if this was a 2.2? 0.22 actually. Okay, that's readable. That's just not readable. Fuck. Let's see, 1.5. Come on. 1.15. Okay, oopsie. Those are both readable. It's not looking great on the 1 stack. But does it need to be? Because it's like not ideal for either of them. You know, the 1 looks bad and the 14 looks bad. Let's see what like a middle stack would be, like a stack of 8 or something, what that would look like. Will give us a stack of 8 and see what that looks like. So we'll put a black capstone on a stack of 8. That's readable. So yeah, it's you know, it's readable. It just doesn't look great. Yeah, I want it to be a little bit better than this. We're almost there. So maybe okay, readable. Not really readable. So what if we do the opposite? Instead of bigger number, what if we do slightly smaller number, slightly smaller number? Okay, that's readable, but it looks like crap, and that one's not very good. I don't know what to do. We're like right there. This is kind of readable, but ideally it's a little bit better. I don't really care that that one's got such a fat overhang, but that one should be a bit thicker. So let's just make the 2 stack a little bit thicker of an outline. Okay, that's looking good. Yeah, this one's completely jacked. So, is there a way we can shift this to be readable by the time we're at the top of the stack? Okay, looking better. We just need to kind of get this bigger and bigger until we find that sweet spot. That's readable. Oh, and the one's not readable. Fuck. It's somewhere in between those two values. So this needs to be like a bit bigger. This needs to be a bit smaller. There's got to be a better way of testing this. Okay, that's readable. That's not readable. Let's see if it's readable here. Yeah, it's readable there. So it's still just a matter of shrinking and playing the delicate balance. God dang it. That's readable. That's readable. It's just that the lower ones are not. It's really close. It's really close. I'm not exactly sure how to fix it. It's just not readable. I think this needs to be lower for the first ones to be readable. I don't know how to do the math to make this work. Damn it, man. This one was pretty close, right? 2 and 8.5 was close. Not readable. That's readable. So we're still not there at the low end. So does this, if we exaggerate this to 2.4, does it make the first ones readable? No. If we shrink it the other way to a flat 2, does that make the first ones readable? Hardly. So then okay, so this needs to be a little bit smaller to make the first one readable. By first one I mean stack order of 2 here. That's pretty close, that's good. And then if we were at the end here of a 14 stack, it's just way off. And then by the time we tweak this, we mess up the readability of the first one, so it's really hard to find the balance here. Because if we make this a less number, it should be more effed up at the higher stack index. Yeah. But it looks okay at the beginning. Yeah. So what if this is just a lower number? Is that way too big of a difference? That's readable. That's readable. and then a middle stack. It could be better. I mean, it's readable, but it's just... Actually, it's kind of cool. Yeah, I kind of like that, actually. Let's see if we had... What does a 3-stack look like? Not bad. What does a 4-stack look like? Not bad. Okay, this is getting really close. Now, what would we do to fix it? Or tweak it in more? Maybe just a... I don't know, that's pretty readable to me. I like that. I like that. And then at a highest stack, it's perfectly readable. I think we're in the sweet spot. I think I like that. Yeah. So I guess the only thing left to do is to do this stuff for our mouse stone render. Because we don't know how to modify these parameters for a member. Because it's a draw function, it's not a field. So I don't know how to modify those. So even though we're copy and pasting it, I don't know exactly what we would do instead to prevent that. But when we're rendering our mouse stone here, when we're stone select 3, that is a mouse stone. So instead of just rendering a normal mouse stone, we're going to be rendering... Let me just... get this indented correctly, and then instead of stack order, we would do... Did I accidentally copy this? No, I didn't. This needs to be here. No, 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 no. Yeah, we would hard code in a stack. Oh, come on. Stack order of 1 for this. Because we don't actually have the field stack order, so we would crash if we just tried this. But now, under our capstone, we will give ourselves self stack order of just 1. So this is actually a shrink of none. So this whole thing would be gone, I think. And then a stack order -1, which would be 0, which would give us... We just need to get rid of the whole shrink. I think. I don't exactly know. Keep the offset. Oh my god. What? This one, comma, plus 58, minus, plus the 1, and then we would get rid of the shrink. And we would keep the -2. Is that right at all? Let's see. Mouse stone. We're looking at the size of our mouse stone. If our mouse stone capstone has the outline now. Yeah, we don't. Because we're modifying by a self X. And it's not a self X, it's a mouse X. Mouse master X. And a mouse master Y. Does that. I really done goofed. We copied over our rectangle object there. We need to copy over our mouse stone. Our circular capstone here. This. Dude, is that not what we did? Circle fill. This is what we copied, was it not? Okay, capstone. I don't think we really need this even. It's just that if you're holding a capstone in your hand in a move type move and you hover over a grid that already is in there, it'll just disappear. So I was thinking maybe we should just take care of that, but it's not super necessary. God dang it, yeah, we did it wrong again. Here, this is what we need to indent. Okay. Edit. Redo paste. Okay. Except we need to give this mouse master. Y master. Stack order of 1. I'm just keeping it simple, even though 1 minus 1 is 0 times shrink is 0. I'm gonna keep it like that to my sanity. We can fix it once we have to. I might just give up on this and just call it good as is. Your laziness. If this doesn't work. So let's see if it works. We're at the, yeah, we're rendering wrong. Instead of mouse master X, we want mouse X grid, I think. I'm going to actually take a look at our old git commit here. At our last commit, what was in our play state in our last commit? Come on. What was our toggle mouse stone? So it was mouse master X, mouse master Y. So we don't want to shift it at all. Because we were shifting the grid, but we're not shifting the grid here, so for the offset, because the grid is not flush with the top left corner. Okay. Yeah, you know, I'm not seeing a shadow on either one of them. Probably because our stack order of 1 doesn't have the, Yep, I can't see it. I'm gonna give up on this. It's not a big deal. We would be copying 40 lines of code just to get one little enhancement. There might be a better way to do this. I mean, I'm sure there is. I just don't know it. This is okay. Actually, why did... Oh, okay. We turn off stones. Right. I think it's okay. I think that's fine. So we fixed that. Took us maybe a little longer than expected, but we've got... We now render same color stones on top of one another where you can actually see them now. So I'm happy with that. So next on our list is more extensive debugging and wind state solution, implementing the wind state detection. So I'm gonna add everything, say added shadow to same color obstacle stones. And that's about all we did. It didn't ask us this yesterday, but I don't know how to get rid of that. Anyways, yeah, I'll see you guys tomorrow and we'll do more debugging and starting the wind state detection.